In a colorful migration, Christmas Island in Australia is crawling with red crabs. Every year, millions of these crabs come out of the forest after the first rainfall of the wet season.
Millions of red crabs once ruled Christmas Island until something invisible arrived and wiped them out almost overnight.
A crab like this is carrying about 100,000 eggs, and she has to shed them directly into the sea if they are to hatch.
Tiny ants, no bigger than your fingernail, sprayed acid into the crab's eyes, leaving the forest floor silent and rotting. Then came the game changer. Scientists released millions of microscopic wasps. What happened next flipped the entire battle. How could something so small bring down an entire empire of ants? And how did it all start with sap-sucking insects hidden in the trees? The island built on crabs. Christmas Island is one of the few places on Earth where an entire ecosystem leans on a single species. The red crabs that live here are not a side attraction, but the architects of the rainforest. For most of the year, these bright red creatures move slowly across the forest floor, eating fallen leaves, seedlings, fruits, and anything else that drops from the canopy. In doing so, they act like a natural cleaning crew. They keep the floor open, stop vegetation from growing too thick, and help nutrients cycle back into the soil. Scientists estimate that more than 40 million red crabs once lived on this small island, roughly 300 crabs per square meter in some areas. Walk through the forest during peak season, and you would have seen crabs under logs, in burrows along tree roots, and crossing narrow paths like a moving carpet. Plants that tried to grow too close together were quickly trimmed down. Species that relied on shady, litter-filled ground struggled to get a foothold. The forest that visitors see today grew around the habitats of these crabs. The most remarkable part of their life happens once a year. When the first rains arrive, the crabs leave their inland burrows and begin a long march toward the ocean. This migration is so massive that roads have to be closed. Rangers set up barriers to guide crabs safely, and cars drive slowly through crawling red streams. Once the crabs reach the shore, the females release their eggs into the sea in time with the lunar cycle. The invasion. The trouble on Christmas Island began quietly. The yellow crazy ant, a small insect barely a few millimeters long, arrived in the early 1900s through ships and cargo. At first, no one paid attention. The ants were tiny, fast-moving, and seemed like just another stowaway species. They blended into the forest floor, hiding under leaves and moving in thin trails that looked harmless. What made these ants different was their structure. They formed massive supercolonies with multiple queens, communicating and coordinating like a single giant organism. Unlike most ant species with one queen per colony, these supercolonies had hundreds of queens, each laying thousands of eggs. The colonies expanded across entire valleys, creating chemical trail networks that spanned hundreds of meters. The ants discovered an advantage that fueled their expansion. They formed partnerships with scale insects, tiny sap-feeding bugs that lived on plants. The ants protected these scales from predators and, in return, harvested honeydew, a sugary liquid the scales produced. This relationship gave the ants unlimited energy. As scale populations exploded, the ants multiplied even faster. Ecosystem collapse. Scientists recorded tens of millions of red crabs dead across Christmas Island. With the crabs gone, the forest's entire foundation shifted almost immediately. Their disappearance halted the natural clearing, aeration, and nutrient cycling they performed every day. Without the crabs breaking down organic material, leaf litter began to build up in thick layers. Decomposition slowed, soil composition changed, and nutrients stayed locked in the debris instead of circulating back into the ground. Seedlings that the crabs once trimmed down sprouted freely, creating dense clusters that clogged long open forest paths. Areas that had remained clear for generations filled with tangled undergrowth, forcing animals to alter their movement routes. Light patterns changed as well. Patches of deep shade and sudden bright openings spread across the forest floor, affecting which plants could survive and where they could grow. Soil that had been constantly turned by millions of moving crabs became denser and less aerated. The island's forests shifted from a crab-maintained system to one driven by slow microbial decomposition, producing uneven fertility across different regions. The collapse spread outward. Bird species that fed on crabs suffered immediate population declines. Others struggled as nesting and foraging habitats changed. Native insects responded to the thicker undergrowth and accumulated plant matter, reshaping local food webs. Small mammals had to navigate a forest that became more tangled and unpredictable each year. Streams were affected too. With no crabs clearing fallen leaves, waterways carried more debris, altering water flow and reducing oxygen levels. These changes disrupted aquatic insects, crustaceans, and fish downstream. Within a short period, the island transformed into a fundamentally different ecosystem, one where plant growth patterns, soil processes, wildlife behavior, and water systems all shifted at once, revealing just how much the rainforest depended on the red crabs to function at all. The first wave of human intervention. Faced with the unstoppable march of the yellow crazy ants, rangers knew they had to act fast. Teams trekked through the dense rainforest, carrying bait that contained slow-acting insecticides designed to target the ants. They spread it carefully across the forest floor, hoping to strike at the super colonies before they could grow even larger. At first it seemed promising. In some areas, ant numbers dropped noticeably. Colonies shrank, and patches of the forest that had been crawling with ants for years briefly saw some relief. Rangers celebrated small victories, knowing that even a temporary slowdown gave native species a chance to recover. Red crabs, for example, were able to migrate in slightly safer corridors, and seedlings once again had a fighting chance to grow in patches cleared of the ant threat. The relief didn't last long. Within 6 to 12 months, treated areas were reinfested, sometimes reaching higher ant densities than before treatment. The ants moved deeper into areas rangers couldn't easily access. Teams had to carry heavy packs of bait across rugged terrain, often in sweltering heat and sticky humidity, just to keep pace with the ants' relentless expansion. Hand-spreading bait required enormous manpower, constant coordination, and continuous monitoring to see whether the treatment was holding. Despite all this effort, rangers were still fighting an uphill battle against one of the world's most aggressive invasive species. The ants' ability to adapt, disperse, and rebuild meant no single intervention could keep them permanently contained. It became a frustrating lesson for conservationists. Traditional manual methods could slow the invasion, but they could never fully stop it. The yellow crazy ants had changed the rules of the game, and humans needed a smarter, more innovative strategy to save the island's fragile ecosystem from total collapse. Flight combat starts. When the scale of the ant invasion became impossible to manage on foot, scientists turned to the sky. Helicopters were brought in to tackle the problem from above, carrying hundreds of kilograms of specialized ant bait. These flights allowed teams to reach dense, remote patches of rainforest that were almost impossible to navigate on foot. From the air, they could blanket entire valleys in a single sweep, targeting the ants' hidden colonies and giving rangers on the ground a fighting chance. Each season, helicopters flew multiple sorties, dropping bait over hundreds of hectares at a time. Pilots had to navigate thick jungle canopies, steep ridges, and unpredictable weather, all while carefully timing the releases to ensure the bait reached the ants without being wasted. Scientists monitored the drops closely, adjusting quantities and locations based on ant activity and environmental conditions. Despite the scale and precision, colonies bounced back within 12 to 18 months. In some areas, ant numbers initially dropped by 70 to 90%, but reinfestation followed wherever bait coverage was incomplete. Some super colonies split into smaller satellite groups, avoiding detection and continuing their spread across the forest floor. Researchers realized that while aerial baiting could significantly reduce numbers, complete eradication through baiting alone was impossible. Even with helicopters, careful planning, and thousands of hours of effort, the yellow crazy ants remained a constant threat. Scientists understood they would need a more innovative long-term solution if Christmas Island's rainforest and red crab populations were ever going to recover. The discovery that changed the battle. The breakthrough came when scientists studying the invasion noticed something surprising about the yellow crazy ants. Hidden in the trees and shrubs were tiny insects called lac scale. These unassuming creatures produced a sugary substance known as honeydew, which the ants relied on for energy. Essentially, the ants were farming the scales, protecting them, and using their sweet secretions to fuel their relentless expansion across the rainforest. The ants' super colonies were only so powerful because the scales fed them consistently. Targeting the ants directly with bait had always been only partially effective, because as long as the honeydew supply continued, new ants would replace the ones that died. Scientists began experimenting with ways to reduce the lac scale population. By cutting off this sugary lifeline, they could weaken the ants naturally. When the scale insects were removed or reduced, ant numbers started to drop. Colonies that had once carpeted entire valleys began to shrink, and the ants became more vulnerable to other control methods. This discovery was a game changer for Christmas Island. By studying the relationships within the ecosystem, researchers found a clever natural way to turn the tables. Suddenly, what seemed like a hopeless war against millions of ants had a strategy that could actually restore balance to the island's rainforest and give the red crabs a fighting chance to recover. The microscopic wasp weapon. The game changed again when researchers stumbled upon a tiny, almost invisible ally, a parasitic wasp that specializes in hunting lac-scale insects. The wasps, from the genus Eretmoceras, were so small they could almost be mistaken for a speck of dust. Yet they carried the potential to turn the battle against the yellow crazy ants on its head. They didn't sting humans or other wildlife. Their sole target was the scale insects, the very creatures that fueled the ants' supercolonies. Before the wasps could be released, scientists had to be certain they were safe. Years of painstaking testing followed in controlled environments. Researchers studied the wasps' behavior, their life cycle, and their interactions with other species on Christmas Island. Every detail mattered because introducing a new species could have unintended consequences. Finally, after thorough observation and analysis, the wasps were approved for controlled release. When the first batches were released, the results were subtle at first. The wasps flew through the rainforest, locating scale insects and laying their eggs inside them. Within weeks, the scale populations began to drop. Without their sugary honeydew supply, the yellow crazy ants started to weaken. Supercolonies that once stretched across valleys and glens were no longer unstoppable. Ants that had been hyper-aggressive became sluggish, and their rapid reproduction slowed dramatically. The magic of this approach was its natural efficiency. Instead of relying solely on chemical baits or large-scale manual removal, the wasps worked quietly, invisibly, and continuously. They targeted the source of the problem, breaking the support system that had allowed millions of ants to dominate the island. Over time, the ecosystem slowly began to recover. Red crabs and other native species survived longer, and the dense carpet of ants that once covered the forest floors started to thin. This tiny army showed that in nature the smallest players can have the biggest impact. By targeting the hidden links in the ecosystem, scientists were able to fight the invasion strategically instead of relying on brute force, offering hope that Christmas Island's rainforest could finally begin to heal. The release of millions. The real turning point came when millions of microscopic wasps were carefully bred and released across the worst-infested areas of Christmas Island. Scientists mapped the supercolonies and targeted zones where yellow crazy ants had reached their densest numbers. Each wasp was tiny, but together they formed a relentless army, invisible to the naked eye yet deadly to the ants' secret allies, the lac-scale insects. At first, the movement was subtle. The wasps flitted through the rainforest canopy, navigating the tangled branches and hidden crevices where scale insects clung to leaves and bark. It was painstaking work for such a small creature, but their instincts were perfect. They located the scales, laid their eggs inside them, and ensured that the next generation of wasps would continue the hunt. Over time, the scale insect's population began to shrink, and the ants started losing the sugary honeydew that had fueled their explosive growth. Over the following year, the impact became visible. Yellow crazy ant colonies that had once carpeted valleys and tree trunks began to falter. The ants became slower, less aggressive, and fewer in number. Entire supercolonies thinned, and their once dominant presence over the forest floor began to fade. Scientists observed that red crabs, which had been nearly wiped out in some areas, were starting to survive their migrations again. Forest floors that had been thick with ants began showing signs of life returning. Seedlings sprouted where they had previously been crushed, and leaf litter cleared, allowing the natural cycle of the rainforest to resume. What made this release so impressive was both its scale and precision. Unlike chemical treatments that could harm other wildlife, the wasps targeted only the ants' allies. Their work was quiet, ongoing, and self-sustaining, gradually turning the ants' own support system against them. Over time, the rainforest began to recover. These millions of tiny wasps became the invisible heroes of Christmas Island. The collapse of the ant empire. Areas that had been covered in thick, moving carpets of ants now showed clear patches where their activity had sharply declined. Scientists visiting these zones saw signs of balance slowly returning to the rainforest for the first time in decades. Ant aggression dropped drastically. Formic acid attacks, which had once killed thousands of red crabs, became rare. Crabs could now move through the undergrowth without constant threat. Their recovery was steady but unmistakable. Seedlings stunted under leaf litter began to grow, and the forest floor slowly returned to a healthier composition. Soil nutrients and moisture stabilized, creating space for small invertebrates to return. Birds and other wildlife also benefited. Ground foraging birds could feed without interference, and insects previously suppressed by the ants began to flourish. Researchers observed the forest regaining structure, with clearer water runoff paths, natural sediment movement, and improved plant growth. Supercolonies that had spanned valleys and numbered in the millions shrank within months after the wasp's introduction. For the first time in decades, the rainforest's rhythm returned. Red crabs, the ecosystem engineers, reclaimed their role. Leaf litter was cleared, new seedlings sprouted, and the forest floor buzzed with life again. The return of the red crabs. As the yellow crazy ants lost their grip on the forest, the red crabs slowly began to reclaim the ground they had once ruled. Young crabs that had barely survived in the shadow of the supercolonies now had a much better chance of reaching adulthood. Seasonal migrations, which had been decimated by the ants' attacks, picked up pace, and the familiar red tide of shells moving from forest to sea returned with renewed strength. Paths that had been eerily quiet for years suddenly came alive again. Forest floors, once littered with fallen leaves and debris that the crabs had once cleared, now saw a rhythmic scuttling as crabs worked tirelessly to reshape their environment. Their digging and foraging helped aerate the soil, move leaf litter, and maintain clear roots through the dense undergrowth. Every claw, every shuffle, was part of a natural cleanup crew that had gone missing for decades. With the red crabs back in force, other parts of the ecosystem began to respond. Seedlings that had sprouted in chaotic patches were pruned and spread, creating a more balanced forest floor. Invertebrates, insects, and even birds benefited from the crab's return, finding restored habitats and more predictable food sources. Streams and waterways that had been blocked by unchecked vegetation now flowed more naturally as crabs cleared debris and maintained open channels. The seasonal migration itself became a spectacle once again. Millions of red crabs moved in synchronized waves toward the ocean to breed, leaving a trail of cleared forest floor in their wake. Researchers and local observers marveled at the scale and coordination of this natural phenomenon. The return of these crabs wasn't just a visual sign of recovery. It signaled the resurgence of an entire ecosystem that depended on their labor. For the first time in decades, Christmas Island looked and felt alive in the way it had centuries ago. The wasps had delivered on the promise scientists hoped for, a natural solution that worked with the ecosystem, not against it. Thanks for watching. See you on the next one.